This is the build an atom basic simulation, right? Ion. And what we're gonna do is we're gonna track the stability of an atom. We're gonna see the mass number, the net charge, and we're gonna see the number of particles that are there, right? This is a priority table, and we're gonna see what really affects the priority table. So if I put neutron in there, the mass increases, right? And we can see one proton, one neutron being added, right? If I add and unlikely, you don't see anything highlighted over here, right? So that means it's not the neutron that defines the type of element that is there, right? So if I put another one in there, I still see nothing over there. The mass is increasing, the number of particles are changing, but neither there's a charge nor you're able to identify the element, right? So I'm just going to take the neutrons out. Now if I put the electrons in, right, you see a charge which is the negative one, right? I put another electron, you see a charge, but you don't see any change in the mass. That means that the electrons don't really contribute much to the mass, neither they define the element, right? You don't see any element being highlighted over here, right? Now I'm going to take the electrons out. I'm going to put back in now a proton, which is a positive. So you see one positive increase, you see the mass number increase, and now you see an element being highlighted, right? So this shows that the protons define how the elements are arranged, right, in the priority table. So I'm going to put another one. So now I'm in 2 plus 2. Mass number is also 2, and you've got 2 protons, right? Right, now I'm going to put one electron to neutralize. This is saying that this is now balanced, right? I'm going to put another one. Now that is also balanced, right? So now the net charge is there, but the mass number is not increasing, right? And the element is not changing either. I'm going to put in 2 more neutrons to make it mass 4, right? So this way you can build any atom. You can see whether it is stable. You can see this is now unstable because it's got not, the neutrons are not balancing, right? Now they're in balance. Now this is positively charged, so I need to put in some electrons in there, probably, right, just to balance it out. So this way you can build several atoms and see what they're like, right? Now I'm gonna come back. I'm gonna play a game, right? And let's go to this back again, and let's play a game. Okay, which one should we go for? Identification in the priority table, mass charge balancing, or identifying the element itself, or just the random one? Should we go with this then? Okay, find the element. So which one is gonna be this atom? Quick. Oh, come on, it's got one yes, one proton. You're right, because it is one proton in there, right? So that's gonna be hydrogen. One. The atom is neutral. Is it neutral? Yes, it's got, yes, very good. So it's got 2 electrons, but 1 proton, so it's negatively charged. It's an ion, right? So check. So that's correct. Smiley for you, right? Okay, let's start over with what? I can only get this. Oh, I started over. Sorry. Okay, so this is gonna be again hydrogen and a 9, right? Next, okay, this one. 5 of them you're gonna click, right? Which one is it now? 10 protons, 12 neutrons, 10 electrons. Hmm. Neon. Neon. Very good. And it is neutral or not? Yes, very good. So the number of electrons and the protons are equal, so neutral atom. Perfect. Okay, next one. Be quick now. I'm just gonna make clicks. Hydrogen. Now neutral or ion? Neutral. Very good. Next. 10, 10, 11. Neon again? Yes, very good. Neutral or ion? Neutral. Perfect. Last one. 8, 8, 10. Oxygen. Okay, is it neutral or ion? Neutral again. Very good. Perfect. Score 10 out of 10. Yay. Oh god. the sound is coming to my headset. So you're not able to hear that, right? I've turned off the video sound. Okay, charge one. What's the net charge? Okay, check. Perfect. Okay, next one. Negatively charged. -1. Perfect. Good. Okay. Now neutral. Okay. Ah. Oh. What happened? Think about it. Read it again. Read again. Ah, yeah, that was one now, right? This is mass, not the charge, right? Okay, it tricked us. Okay, now the mass number again. Mass number is protons and neutrons summed up, right? So what is now? 17. Okay, let me go to 17. We went to 23. 17. Perfect. Last one. What's the mass number? 14. When? Oh, we had one missed try. Okay. Okay, next one. Hmm. What's this? What's missing over here? What could it be? Atomic number is missing or the mass number is missing? Which one is missing? The mass number is missing. And what's that gotta be? 38. Okay. 16 plus 16. 30. 38. Huh? Okay, sorry. 4 plus 1. 35, shouldn't it be? Is that so? Ah, you're wrong. I got it. 35. How you got to 38? It's one even number, one odd number. How would it give an even sum? It should always give you an odd sum. Maths rule, right? Okay, next one. The charge is missing. So what's the charge? -1. Good. Next. What's missing? How much? Perfect. Last, second last. Yeah. Hmm. Last. What's missing now? Yes, because 0 would have no element, right? Okay. So what is it now? 2, because 2 protons. So yeah. Perfect. You've done it. I'm not gonna go for the random one, right? Okay. So I wanted to show you this lab, and this is gonna be more fun. You can play with this, right? So these are the electron geometries you can see, like linear if you want, or the molecular geometry if you want, right? So it will tell you what sort of it, but this is a bit advanced, right? And the bond angles can be shown to you, right? And you can decide what kind of behavior you want to have, right? So what let me see, real molecules. I think this one is gonna show the actual molecule. Okay. No, I don't think so. We need to. Oh, no, that's not the one. Okay. We are going to look into a different one, right? That's, I think, the basic shapes one. Okay. There are two simulations for that, right? This one is going to give me a 3D model, I guess. One gives a 3D model, right? Very beautiful one, right? The models. Okay. So, molecular geometry, show bond angles, real molecules we're working with. No, I don't think so. There needs to be another app. Just saying it a minute. Ah, there we go. Yeah, sorry, my bad. That's molecule building. We're gonna look at. Okay, look at this one. Now you can play along with this, right, in your free time as well. So you can go into the playground and see what you can go for, right? I'm just gonna go with single ones, right? Let's say if you talk about water, so you can see the 3D model of how this actually looks like, right? This is the realistic model, and this is the line model, right? Where the when the electron bonds are represented as lines. Now this is water, right? This is how the water molecule looks like, right? So if you go for let's say multiple of them, right? So oxygen, hydrogen, and another oxygen, another hydrogen. We call it hydrogen peroxide, right? Very reactive and very volatile liquid. So this is how it is. And the hydrogen, you see, they are arranged on the opposite edges, right? They are not balanced, right? They're countering each other's push, right? And we can go to, let's say, nitrogen dioxide, right? So that's gonna be like this, right? Oppositely arranged particles you can see. And let's say if you talk about carbon dioxide, right, the one we that we breathe, respiration, that's gonna be like this, okay. And if I go for, right, uh, you can say hmm, let's go with more, right? Yeah, this one, right? Ammonia, right? How the ammonia looks like, it's gonna have a lone pair as well, right? So the ammonia is like this, right? It's the three hydrogens are pushed to one side. Why? Because there's a lone pair on the other one, right? So let me just reopen that tab in which we had the lone pair option, right? I'm going to show you how ammonia is going to look like, right? So it's got three hydrogens, but let me open the other one, right? The Vesper one, right? This is what we need. Yeah. Over here, we have the lone pair option, right? So this, how it's going to look like, another hydrogen in there. This is a lone pair, right? This is the lone pair, two electrons which did not participate in the reaction, right? So what they do is that they push all the hydrogens down. No matter how many times I try to arrange this, right, it just pulls them onto one side, right? And wherever I push this, the electrons, the hydrogens just run away from it, right? So this shows how this lone pair, two extra electrons and nitrogen are pushing the hydrogens, and it is no more a planar, right? It's a pyramidal or tetrahedral form, right? I was discussing this with your elder brother yesterday for one of his questions, right? We were trying to crack that question. So for this, we were going through this, and we saw that there's a lone pair in there, right? We were discussing this, right? So you can build these, and you can explore different elements and how some of these are they look like in real life, right? Now this is the model generator that you can use for your general working, and help yourself, right, in getting to know the molecules and their names and what they can be, right? You can go to the playground and you can just try let's see what this forms, right? Does not make anything. If I just put oxygen in there and maybe some hydrogen in there, all right, it doesn't want to react because the bonds are complete. So let's say I've got carbon, methane, right, gas. So this is propane. You would know about liquid propane gas, right, or liquid petroleum gas. This is what the LPG is like, right? This is how the molecule is like. So you can see the 3D molecule that this is how it looks like, right? More looks more like a some sort of alienistic, squishy, whatever animal, right? So this is what it is, right? But if I want to, let's say, create, I remove one hydrogen and remove this and put one chlorine in there, right? And then I'm just gonna join them together, right, with one another. This is going to create vinyl chloride, right? So let me just remove this. I'm gonna put two chlorines over there, right? This and this. Now this is vinyl chloride, right? Uh, this whole is gonna join here and this, right? Now dichloropropane, and if we create a long chain of this is the PVC material that you have in the form of plastics, right? The PVC plastic. So that is polyvinyl chloride. That means we take these chloropropane molecules and just convert them into long chains, right? So this is what it is going to look like, right? Now ammonia is there, right? If I put another one, right? It does not make a molecular ion, unfortunately, but if they did have the option, we could put this hydrogen in there and convert it into an ammonium ion. We can see how the lone pair is not disturbed because of this, right? So it's a playground. You can make different combinations, get to know the names of compounds, right? How atoms are joining together, right? Are you clear so far? So just explore this, a fun tool to work with, right?